Intro music with visuals of iconic Toyotas like the Supra, Hilux, and Land Cruiser. Hello and welcome to Ude Repo. Today, we're diving into a legend, a myth that has echoed through garages and across continents for decades. Why do Toyotas seem to run forever? We've all heard the stories: a beat-up pickup truck still hauling loads after 30 years, a sports car engine that just begs for more power, and odometers ticking past 1,000,000 miles. Today, we're not just repeating the legends. We're dissecting them, looking at the nuts, bolts, and brilliant engineering that created the Toyota engines that simply refuse to die. Visuals of the 2JZ GTE engine on a stand, clean and polished. Let's start with an icon, a titan of the tuning world, the 2JZ GTE. When Toyota engineers designed this engine in the late 1980s for the Supra, they weren't just building a powerful engine, they were building a fortress. The secret begins with the foundation, the engine block. It's made from cast iron, a material known for its immense strength and rigidity. This wasn't just any cast iron, it was a high-grade, meticulously crafted block designed to withstand incredible pressures. This robust construction meant the 2JZ could handle far more power than its stock output of around 320 horsepower. It was over-engineered to a degree that seems almost absurd by modern standards, where every ounce of weight is scrutinized. Close-up shots of a 2JZ's crankshaft and connecting rods. Inside this iron fortress, the components are just as tough. The 2JZ features a forged steel crankshaft, with 7 massive main bearings supporting it. This design provides incredible stability and balance, even at screamingly high RPMs. The connecting rods are also incredibly stout, capable of handling the immense forces generated by increased turbo boost and aggressive tuning. It's this combination of a strong block and a bulletproof rotating assembly that allows tuners to reliably extract 1,000 horsepower or more from these engines. Toyota's philosophy was simple: build it to last, then build it stronger. This commitment to over-engineering is the core reason the 2JZ has become a legend in the performance world. It doesn't just make power, it survives it. Transition to visuals of a Toyota Hilux in a rugged, remote environment, like a desert or jungle. Now, let's shift gears from the racetrack to the most unforgiving places on Earth. This is the domain of the Toyota Hilux and its equally legendary diesel engines, like the 2L, 3L, and later the 1KD. For decades, the Hilux has been the vehicle of choice in war zones, remote villages in Africa, and the Australian outback. These are places where a breakdown isn't an inconvenience, it can be a life-or-death situation. The engines powering these trucks were built with a different kind of immortality in mind. They weren't designed for blistering speed, but for relentless, unwavering reliability under the worst conditions imaginable. Visuals of a simple, old-school Toyota diesel engine, perhaps a 3L, with mechanics working on it in a basic workshop. The design philosophy behind these engines was simplicity and serviceability. They featured mechanical fuel injection systems that were far less complex than modern common rail setups. This meant that if something did go wrong in the middle of nowhere, a reasonably skilled mechanic with basic tools could often get it running again. There were no complex electronics or sensors to fail, just pure, robust mechanical engineering. The metallurgy was, once again, key. These engines used heavy-duty components and were designed to run at low stress levels. They weren't making a lot of power for their size, which meant the internal parts were never pushed to their limits. Shots of a 1,000,000-mile odometer on a Toyota, followed by news clippings or photos of high-mileage Toyotas from Nigeria and India. This brings us to the 1,000,000-mile myth. Is it a myth? Not at all. There are countless documented cases of Toyotas, particularly diesel Land Cruisers and Hiluxes in places like Nigeria and India, clocking over 1,000,000 miles on their original engines. In these countries, vehicles are essential assets, and they are maintained and driven until they physically cannot move anymore. The low-stress design of these Toyota engines, combined with regular, albeit basic, maintenance, allows them to achieve this incredible longevity. They were built with loose tolerances, which might sound counterintuitive. But this design allows them to handle varying fuel quality and less than ideal operating conditions without seizing up or failing catastrophically. Side-by-side comparison animation, a modern, high-strung engine versus an old-school Toyota diesel engine. The modern engine has tighter tolerances and more complex parts, while the Toyota engine is simpler and more robust. So, what's the common thread between a high-performance 2JZ and a workhorse Hilux diesel? It's a deep-rooted engineering culture at Toyota known as the Toyota Production System or TPS, which prioritizes quality and long-term reliability above all else. Whether it was building an engine to handle massive turbo boost or one that could run on questionable fuel for 500,000 miles, the principle was the same: identify the potential points of failure and then radically over-engineer them. They didn't cut corners to save a few dollars on a crankshaft or use a lighter-duty block to save a few pounds. They built for a worst-case scenario, and in doing so, they created engines that could outlast the very vehicles they were put in. Slow-motion cinematic shots of both a Supra drifting and a Hilux climbing a rocky hill. This is the magic behind the legend. It isn't magic at all, but a deliberate, methodical, and expensive commitment to building things that last. From the cast-iron heart of the 2JZ to the simple, unkillable nature of the Hilux diesels, Toyota's reputation for reliability was forged in steel and proven over millions of miles. They are the engines that refuse to die because they were engineered for immortality from the very start. Outro music begins. What are your favorite legendary engines? Let me know in the comments below. And if you enjoyed this deep dive into automotive engineering, make sure to subscribe to Ude Repo and hit that notification bell so you don't miss our next video. Thanks for watching.